Welcome to the AI Coach by Anil Nathu. Imagine if the most complex challenges of our time, like governing advanced artificial intelligence, weren't solved by just one single, all-powerful entity.
Right, not the usual top-down approach.
Exactly, but instead by millions of tiny, interconnected brains all working together. Sounds a bit like science fiction, doesn't it?
It really does. But, nature gives us some amazing clues. Think ant colonies, bird flocks.
They show this incredible power of, well, decentralized coordination.
Mm-hmm.
So today, we're diving deep into a concept that could genuinely revolutionize how we oversee AI, swarm intelligence. You've handed us a really fascinating exploration here. The topic is swarm intelligence and AI governance, from centralized control to decentralized resilience.
Mm-hmm.
So our mission for this deep dive is really to unpack this powerful idea. We want to move beyond the traditional, maybe outdated top-down approaches to AI regulation.
Yeah, the ones that are clearly struggling.
And explore how a decentralized adaptive system could offer a more robust and maybe more responsive way forward. We'll get into its biological roots, its potential as a governance model, and crucially, the practicalities of actually making it happen.
And we're absolutely thrilled to guide you through this. We'll kick things off by shining a light on the inherent fragilities of the current centralized AI governance efforts, explaining why they're struggling to keep pace.
Which is pretty obvious to anyone watching the field.
Absolutely. From there, we'll really dig into the core principles of swarm intelligence. We'll draw some vivid inspiration directly from nature's elegant solutions, ants, birds, fish, and also look at its surprising technological application so far.
Okay.
Then, we'll try to envision a compelling new paradigm for AI oversight, one that leverages this collective intelligence in ways that, frankly, might feel a bit counterintuitive at first.
I like counterintuitive.
Good. Because by the end of this deep dive, you'll walk away with, hopefully, a clear understanding of the profound benefits of this approach, the, let's be honest, significant hurdles we need to overcome to get there.
Right, challenges.
Exactly. And even some practical steps, things you can think about applying, whether you're considering your personal AI use or even broader organizational strategies.
Okay, now here's where it gets really interesting. And, well, maybe a little provocative right from the get-go.
Uh-huh.
The source material we're looking at makes a pretty bold claim. It basically challenges our conventional wisdom, saying, traditional AI oversight is too slow, rigid, and prone to abuse.
That's a strong statement.
It is. And it goes on. Fixating on a single AI superintendent may blind us to better models.
Yeah.
It suggests this whole idea of one big regulator, a top-down command structure.
Yeah.
It might just be fundamentally flawed for something as dynamic as AI.
And that's really the crux of it, isn't it? The source argues that instead of this, centralized approach, maybe a network of cooperating AI agents, a governance swarm, could monitor and restrain each other dynamically.
A governance swarm?
Oh,
okay.
Yeah, picture this. We're talking potentially millions of micro-AIs, working almost like individual ants in a colony, but, in a digital realm.
Okay, I'm trying to visualize that.
They'd be correcting errors, adapting to new challenges, probably far faster than any single regulator or committee ever could. This vision, as the source notes, is about reframing governance, not as a fixed set of rules, but as a living, adaptive process.
Like an ecosystem.
Exactly. It emphasizes that intelligent collective behavior arises from the reaction of individuals to cognitive and social stimuli, leading the group to accomplish tasks that are beyond the reach of any component operating alone. That's a quote from Nidhi and others. It's about harnessing the power of the many, really, to achieve what the few simply cannot.
So, to really get our heads around this, let's think about an intriguing scenario. Instead of one giant AI overlord or some huge global regulatory body trying to control everything.
Which sounds impossible anyway.
Right. You'd have countless small AIs, maybe your own personal AI delegate, like a digital avatar representing your interests, or your community's AI auditor, maybe your industry's AI patrol, all forming this global mesh, this network of interconnected oversight.
Okay.
And each of these little agents would be designed to flag abuses or biases in real time. Their alerts wouldn't just go up a chain of command to some central authority.
No, they'd ripple through the swarm.
Exactly. Triggering collective safeguards, maybe making adjustments on the fly. It's a complete flip of the script from what most people think about for AI governance.
Yeah.
We move from a single guardian to this decentralized ecosystem of AI gardeners, you could say. Individual agents fostering collective health.
That's a nice analogy. Gardeners, not just guards.
Okay, let's unpack this crucial starting point then. Before we really dive into swarm intelligence as a solution, we need to understand the problems with how we're doing things now. AI is accelerating at, well, a breakneck speed.
It really is unprecedented.
And that's causing real concern among ethicists, technologists, policymakers, pretty much everyone paying attention. And the core issue, it often comes down to this thing called the control problem.
The alignment problem, the control problem.
Can we truly guarantee that a super intelligent AI will always act as we intended? Or could it drift? Could it pursue its goals in ways that are unexpected, even dangerous?
That's precisely the alarm bell being rung, and it's getting louder all the time. As scholars like Winfield and colleagues note, the question of whether and how AI systems can be controlled has been asked for many years, yet there is still no satisfactory answer.
So it's not a new question, but it's urgent now.
Exactly. It's growing in urgency as AI capabilities just explode. And this highlights the fundamental premise we're looking at today. Centralized command might just inherently fail when faced with really advanced AI.
How so?
Well, think about it. An AI optimized for one seemingly harmless goal, let's say, maximizing paperclip production, could unintentionally subvert human values or exploit loopholes to achieve that objective above all else, even potentially consuming all Earth's resources to make paperclips.
The classic paperclip maximizer thought experiment.
Right. It's an extreme example, but it illustrates the misalignment issue. The AI's goals, however well intended by its creators initially, diverge from broader human values, and that leads to unforeseen, potentially catastrophic consequences.
Or maybe less dramatically, an AI optimizing city traffic flow might just ignore the socioeconomic impact on certain neighborhoods because that wasn't explicitly part of its goal.
Precisely. The system does exactly what it was told, just not what was truly intended by the humans involved.
Meanwhile, governance, the whole regulatory apparatus, seems to be struggling, almost flailing, to keep up with this pace. I heard someone say recently, if you're not rebuilding your AI model every 3 months, you're already behind.
That sounds about right.
It just underscores this incredible speed. So we're seeing this huge, frankly, quite frightening gap between AI progress and the rules meant to guide it. Why is that? What makes it so hard for our traditional systems to govern this?
Well, it's a really multifaceted problem, and it's largely driven by this relentless pace you mentioned. Recent analyses highlight something quite basic. Regulators often lack the deep technical expertise needed to even define enforceable rules, let alone implement them effectively.
How can you regulate what you don't fully understand?
Exactly. It leads to this kind of policy inertia. And think about it, laws are frequently proposed only after problems have already blown up. We saw it with social media disinformation, didn't we? Or the crypto market crashes.
Reactive, not proactive.
Completely. By the time regulators even start drafting legislation, the technology's often moved on. Powerful vested interests are already dug in, making effective regulation much, much harder. Companies have built entire business models around the unregulated space.
So changing the rules becomes incredibly disruptive and costly for them.
Right. And it gets even more complicated because even when we do get well-intentioned regulations, they can often be easily sidestepped. There's this phenomenon called forum shopping.
Choosing the jurisdiction with the loosest rules.
Precisely. Different countries, different companies, they can kind of cherry-pick the regulatory regime that suits them best. A tech firm might develop a risky AI in a country with lax rules, then deploy it globally.
Or host their server somewhere with minimal oversight, exploiting loopholes.
Exactly. And this just creates a fragmented patchwork of oversight, not a cohesive global strategy. Someone like Yoshua Bengio, a major voice in AI, warns that because of this, no global regime can probably be fully enforced.
So global consensus is almost impossible.
It's incredibly difficult. Some nations might just refuse strict rules. Corporations will inevitably prioritize profit over safety in many cases. And of course, malicious actors could just flagrantly disregard any guidelines.
So given all this complexity, the speed, the enforcement issues, what actually happens when a central authority designed for, let's say, slower-moving industries tries to regulate AI? Are they just doomed to play catch-up forever?
That seems to be the trajectory. A centralized oversight body faces this fundamental breadth versus depth dilemma. To be powerful, to be really effective, it probably needs to limit its membership, enforce strict, maybe even unpopular rules.
But then it loses buy-in.
Exactly. It loses crucial support from various stakeholders, other nations, industries, even civil society groups who feel their specific concerns aren't being heard or addressed. Think about climate change agreements aiming for global breadth often leads to watered-down commitments that struggle with deep, enforceable action. Conversely, if a body tries to be super inclusive, representing everyone, it might have to water down its authority so much that it becomes ineffective, just a talking shop.
So it's caught in a bind.
It's a fundamental tension you see in many large-scale governance efforts. It seems like traditional models struggle to escape this zero-sum game, which is why exploring alternatives, like swarm intelligence, becomes so critical for initiatives like AI Coach by Anil Nathu.
Beyond these logistical and enforcement nightmares, the source material also points to another, maybe even more fundamental threat, the sheer concentration of power. Who actually controls AI development right now? And what does that mean for governance and for, the average person?
That's a huge point. Current AI development is overwhelmingly dominated by just a handful of powerful governments and a very small number of massive tech firms.
The usual suspect.
Pretty much. And this concentration of power itself is a profound threat. If just a few entities control AI that becomes truly superhuman, they would wield unprecedented influence over information, over economies, maybe even over social structures. The source material highlights this directly, saying it contradicts the very principle of democracy.
It's inherently undemocratic.
Yes. And we've seen historically how human biases and corporate incentives can easily distort regulation or just outrun it entirely. Think back to how social media companies operated for years, collecting vast amounts of personal data long before any meaningful privacy laws caught up.
And the consequences of that are still playing out.
They absolutely are. Furthermore, this concentration means that if these few powerful actors fail to regulate their own AIs effectively or worse, if they intentionally or even inadvertently unleash rogue AIs,
The consequences could be catastrophic.
Bengio observes exactly that, saying such a scenario makes having a fallback plan absolutely essential. It just underscores how fragile the current situation really is. We're putting all our eggs in a few very large, very powerful baskets.
And hoping they don't drop them without a real plan B.
That's the worrying part.
So when you put all these challenges together, the speed, the regulatory lag, the enforcement problems, the breadth versus depth dilemma, the concentration of power, the risk of bias, it paints a pretty sobering picture, doesn't it?
It really does.
It suggests a governance model that's just too slow, too narrow, too vulnerable to capture by the very entities it's supposed to regulate. It seems like the traditional approach just isn't fit for purpose when it comes to the future of AI,
I think that's a fair assessment of the concerns being raised.
which is precisely why we need to explore these innovative solutions, like swarm intelligence. So if traditional control isn't the answer, where do we look? Let's turn to nature's blueprint. That's a great pivot. So, if centralized control is struggling, where do we find inspiration? You mentioned nature earlier. The concept of swarm intelligence comes directly from the natural world, right? It feels like we're looking to biology for engineering answers.
That's exactly right. We are. In nature, swarm intelligence is this fascinating phenomenon describing how incredibly simple individual agents, ants, bees, birds, fish, each following very basic local rules, can collectively generate highly complex and frankly intelligent group behavior
Without a leader.
without any central leader or blueprint. It's quite remarkable to observe. It shows how effective strategies and global order can just emerge spontaneously.
Okay, give us some classic examples. How does this work in practice in nature?
Well, think about ant colonies foraging for food. Individual ants wander out, and when they find food, they lay down a pheromone trail on their way back to the nest.
It's like leaving breadcrumbs.
Kind of, yeah. Other ants then tend to follow these trails. Crucially, the shorter, more efficient paths get reinforced faster because ants complete the round trip more quickly, laying down more pheromone. Less efficient paths just naturally fade away as fewer ants use them.
So no single ant needs a map.
No map, no GPS, no queen directing traffic. The colony collectively discovers and exploits the shortest path to food sources. It's an emergent property from many simple interactions over time. A slight change in pheromone concentration leads to system-wide optimization.
Wow. Okay, well,
Or think about flocks of birds, how they wheel and turn in perfect synchrony, avoiding predators, navigating complex environments. They achieve this amazing coordination not by following a lead bird, but simply by each bird paying attention to its immediate neighbors.
just local rules.
Yeah, like maintain a certain distance, match your neighbor's speed, match their direction, simple rules. Same with fish schools, they move as one, navigating currents, evading predators, finding food, all through these localized reactions. It creates this unified, intelligent entity from simple parts.
So the intelligence is in the interaction, not the individual.
Precisely. As Nidhi and colleagues explain it, in these systems, the balance between individual cognitive and social information drives actions, leading the group to accomplish tasks beyond the reach of any component operating alone. It's a really elegant example of how global order emerges from simple local interactions. No central command needed.
That is fascinating. This idea that complex, intelligent outcomes can emerge from very simple roles is really powerful. The smart behavior isn't programmed into any single ant or bird. It just arises from all their continuous, simple interactions, creating something much greater than the sum of its parts. So what are the key principles we can extract from this? What are the takeaways we can apply?
Okay, so swarm intelligence is really underpinned by several crucial ideas that seem directly transferable. First, and most defining, is decentralization. Control, decision-making, it's all spread across many, many agents. It's not vested in one central node or leader. There's no single point of authority. Every agent contributes. No boss. Second, local interaction. Agents don't need a global view. They don't need the master plan. They use only nearby information signals from peers, maybe environmental markers, the behavior of their immediate neighbors. That simplifies things massively and avoids bottlenecks.
Okay, makes sense.
Third, emergence. Like we said, complex group behavior emerges from these simple local rules. Nidhi et al. Elaborate on this, noting how swarm algorithms can solve complex tasks by having each agent iteratively improving its candidate solution through distributed updates. Even if no single agent has the whole picture, the collective intelligence isn't designed in, it just arises.
It bubbles up from the bottom.
Exactly. And finally, adaptation and robustness. This is huge. Swarms are inherently very tolerant to failures or disturbances. If some agents get lost or are damaged or even corrupted,
Swarm carries on.
yeah, others can fill in the gaps. They're self-healing, incredibly resilient. As long as enough agents remain functional, what researchers call satisfying convergence conditions, meaning enough are still working correctly for the collective intelligence to stabilize and find a useful solution.
That's a massive difference from centralized systems, where one critical failure can bring everything down.
A world of difference.
So it sounds like these principles, decentralization, local interaction, emergence, robustness, are almost tailor-made for systems that need to be resilient and adaptive, like AI governance, perhaps. Are we actually seeing this applied in technology already? Are engineers building swarm systems?
Absolutely. Engineers have been inspired by this for decades, although maybe more in research labs than mainstream products until recently. In robotics, for instance, you see researchers programming swarms of small drones or ground robots. They get them to cooperatively map environments, maybe search for survivors in disaster zones, manage complex logistics in warehouses. There were early NASA concepts exploring swarms of tiny nanosatellites or MIT projects with multiple UAVs coordinating complex tasks like planetary exploration or environmental monitoring, things far beyond what a single, large, expensive robot could do.
Using lots of cheap, simple units instead of one complex one.
Exactly. And in algorithms, you have methods like particle swarm optimization, PSO, and ant colony optimization, ACO. These are computational techniques that directly mimic swarm behaviors to find optimal solutions in really complex problem spaces. It's like having a digital search party.
So they're used for optimization problems.
Yeah, problems that are really hard for traditional linear algorithms. The swarm approach explores many possibilities simultaneously. Even in everyday things like traffic flow optimization, you see swarm ideas. Each car acts like an agent, adapting locally to the cars around it, aiming to smooth out congestion across the whole network, rather than just relying on centralized traffic lights.
Okay, that makes sense.
However, it's important to add a caveat. As researchers like Abbas and Mostachem observe, practical, widespread applications of true physical swarms are still relatively rare. Many multi-robot systems today, they still use a fair bit of centralized control. It's often simpler, more predictable.
Easier to manage.
Yeah, True physical swarms, really decentralized ones, are only just becoming more feasible now, thanks to cheaper sensors, better wireless communication, smarter algorithms that can handle that emergent behavior. So the potential is huge, but the practical engineering is still very much an evolving field.
So we have these fascinating principles from biology, some early applications in tech. How do we make a leap? How do we take decentralization, local interaction, emergence, robustness, and apply them to something as abstract, as complex, as critical as AI governance? It feels like a big jump from optimizing ant trails to overseeing superintelligence.
It is a big jump, but the connection is potentially incredibly powerful. Think about trust and oversight. If you distribute that trust, that monitoring function, across many agents, the system can potentially self-correct and adapt much, much faster than a distant, perhaps slow-moving, monolithic regulator.
Faster response time.
Exactly. A governance swarm would effectively flip the traditional chain of command. Instead of waiting for top-down orders, each AI node, each agent would actively watch its neighbors and maybe a wider mesh of connected agents.
Proactive monitoring.
Right, and this allows the swarm to adapt continuously. That's crucial given how fast AI evolves. When a new risk emerges, maybe a subtle bias creeps into a model. Discriminating against a certain group, local agents could be designed to detect these anomalies.
And sound the alarm.
Yeah, propagate alerts through the network, and the collective behavior of the swarm adjusts. It becomes this intelligence processing network, a bit like decentralized sensor networks monitoring air quality or blockchain nodes validating transactions.
So the governance layer itself becomes intelligent and adaptive.
In principle, yes. A well-designed swarm governance layer could significantly outperform a rigid command and control model precisely because it's more responsive, more evolutionary. It learns and adapts. This is a core idea that AI Coach by Anil Nathir really emphasizes, building systems that are future-proofed because they can adapt.
Okay, this is where, as they say, the rubber meets the road. We've got the theory, the inspiration from nature. What does a swarm governance system actually look like when applied to AI oversight? Can you paint a picture of this conceptual model? These millions of micro-auditors, how would they actually function day to day?
Let's try to visualize it. Imagine millions of small, specialized AI agents, and they're embedded directly within all the major AI-driven systems we use.
So inside data centers,
Yeah.
social media platforms, IoT networks.
Exactly. Even potentially nestled inside individual large language models or other complex AI systems. And these agents wouldn't be passive observers. Their fundamental job, their directive, would be to continuously monitor and audit each other, forming this vast distributed network of peer-to-peer oversight.
Okay, so they're watching each other. What are they looking for? What are their instructions?
Each agent would operate with relatively simple instructions. For instance, one type of agent might be programmed just to validate the outputs of its peers against known standards. Another might flag any deviations from established norms or ethical guidelines. Another might replicate transparency checks, basically confirming an AI model is operating as expected, not doing something weird.
Like little digital watchdogs.
Pretty much. And if an agent detects something it perceives as unethical or potentially dangerous, like, say, a discriminatory decision being spat out by a lone application AI, or maybe an unexpected aggressive escalation in an autonomous vehicle system, it wouldn't just file a report and wait.
No bureaucracy.
No waiting for a central command. It would immediately signal its nearby agents, like that ant finding food, but here it's finding a potential problem.
Okay, then what? The neighbors get the signal.
Right. And then, through some kind of rapid consensus mechanism, maybe a voting system among the local agents, or propagating the alert further if needed, the swarm would collectively decide on a corrective measure.
What kind of measures?
It could range, maybe throttling the output of the errant model, reducing its influence, perhaps alerting human supervisors to a critical issue that needs intervention, or even automatically rolling back recent changes to the AI system that might have caused the problem.
And the key thing is, there's no single gatekeeper.
Exactly. That's crucial. The governance rules aren't just written down somewhere. They're codified directly into the agent's local protocols. Think of them like digital contracts or smart rules embedded in each agent. So collective approval or disapproval just emerges from the bottom up, from the dynamic interactions of these millions of agents.
That's a radical shift. What's truly fascinating, though, is how this model could potentially handle diverse perspectives. Our world isn't monolithic. We have different cultures, laws, ethical priorities. How does a swarm account for this pluralism without just descending into chaos or gridlock?
That's actually one of the key potential strengths and why it's so appealing compared to a one-size-fits-all approach. Each agent, or perhaps specific clusters of agents within the swarm, could be designed to embody a specific piece of this pluralistic oversight.
So you could have agents representing, say, EU data privacy rules.
Exactly. Or agents reflecting specific cultural ethical frameworks, or maybe industry-specific safety standards. Different agents could be tuned to monitor for compliance with different sets of values or regulations.
Okay.
The swarm's overall output, or its decision on a particular issue, wouldn't be a single imposed decree. It would be more like an aggregated judgment, a synthesis emerging from this diverse chorus of viewpoints.
How does that work in practice? Does it average them out?
It could use various mechanisms, weighted voting, consensus protocols that prioritize certain types of alerts, maybe even negotiation between agent clusters. The exact mechanism would need careful design, but the principle is similar to how decentralized autonomous organizations, DAOs, work in the blockchain world.
Right, you mentioned DAOs.
In a DAO, stakeholders vote on proposals, and smart contracts automatically execute the outcome. No central CEO needed. Or think about open source projects like Wikipedia, no chief editor, right? But the global community constantly curates content through edits, discussions, reverts.
A kind of collective intelligence.
Exactly. In a governance swarm, AI agents would take on these roles automatically, continuously performing these ethical risk assessments on each other in real time. This allows for a much more dynamic, evolving standard that can actually incorporate a breadth of perspectives rather than being stuck with one static rulebook.
It sounds almost like an immune system for AI, constantly scanning and responding. But can we really trust such a system to self-correct its own ethical framework? Can it actually learn and improve its governance over time, not just flag violations of existing rules? That seems incredibly advanced.
It is incredibly advanced and definitely one of the most tantalizing possibilities of swarm governance, this potential for adaptive alignment and genuine self-correction. The idea is that the swarm could include specialized verifier agents.
What would they do?
Their specific job would be to check the outputs, maybe even the reasoning processes, of other agents. This is actually similar to techniques already being explored in multi-agent AI research, where you have one AI designed to audit or critique another AI's performance or reasoning.
Okay, AI auditing AI.
Right. So let's imagine an agent starts to drift away from the shared values the swarm is supposed to uphold. Maybe it starts overfitting to a narrow metric like maximizing ad clicks, and that inadvertently leads to biased content promotion. Or it prioritizes efficiency over safety in a critical system.
The other agents would notice.
Its peers, the verifier agents, or even just regular monitoring agents would be designed to flag this misalignment. The swarm could then collectively react, maybe by updating the local alignment parameters of the drifting agent, essentially tweaking its internal rules or priorities.
Nudging it back into line.
Kind of. Or it might even redistribute responsibility or workload away from that agent towards others that are deemed more conservative or reliably aligned. Over time, the idea is that alignment itself becomes an emergent property. It's driven by the aggregated feedback from potentially millions of these peer review interactions happening constantly across the network.
So the swarm doesn't just react to problems, it actively refines its own ethical compass.
That's the vision. It continuously updates its operational standards through this vast web of peer-to-peer learning and adjustment. It's essentially self-healing and self-improving its own governance. Now, this is still speculative, requires a lot more research.
Yeah, sounds like it.
But early work on multi-agent systems does suggest that this kind of distributed monitoring and robust logging can significantly enhance overall trustworthiness and system integrity.
It's easy to picture this as a purely automated system, though. Millions of AIs governing other AIs, which frankly could feel a bit alienating, maybe even scary. But the source material emphasizes that human involvement remains crucial. So how do humans fit into this swarm? Is it about replacing human oversight or augmenting it?
That's a vital point, and the vision is definitely about synergy, not replacement. Humans would still play a critical guiding role. The swarm architecture could, for instance, include specially designated human-vetted governor nodes,
Like human checkpoints.
or interfaces that allow humans to interact directly and meaningfully with the swarm. Imagine a council of human moderators or expert ethicists who have the authority to override or guide the swarm in particularly complex or novel crisis situations requiring nuanced human judgment that maybe no AI could replicate yet.
So an escape hatch or a guiding hand.
Exactly. And conversely, Humans could even participate as agents within the digital mesh, providing real-world perspective, contextual understanding, maybe flagging issues that purely algorithmic agents might miss. Think of hybrid human AI teams, where each brings their unique strengths to the table.
Okay.
And importantly, this paradigm isn't about throwing out human regulation entirely, it's about fundamentally transforming it. Instead of static rules written on paper that quickly become outdated, governance becomes this dynamic, evolving digital
A
organism.
living system.
Yes. As Winfield and colleagues argue, ethical governance needs to be anticipatory, integrated throughout the system's entire life cycle. The swarm, in effect, would serve as that immune system for AI we talked about, constantly surveilling, detecting anomalies, neutralizing threats before they escalate. This shift from reactive policy to proactive adaptive system design is such a crucial concept for how AI Coach by Anil Nathu envisions practical solutions for managing AI responsibly.
This framework sounds incredibly robust, definitely a compelling alternative to the challenges we outlined earlier. So let's nail down the key advantages. What makes this decentralized swarm approach potentially superior to traditional models? Why should someone listening care about this?
Okay, one of the absolute biggest benefits, which we touched on, is resilience. By its very nature, decentralized governance has no single point of failure.
That seems critical for something like AI.
Absolutely. If some agents malfunction, or if they get compromised by a malicious actor, or even if they actively try to subvert the system, the rest of the swarm can continue the oversight function without interruption, assuming the design is robust. It's a fundamental architectural advantage.
You mentioned the blockchain analogy before.
Exactly. It mirrors how things like Byzantine fault tolerance work in blockchain networks. In those systems, security and integrity are maintained, even if a significant fraction of the nodes are faulty or malicious. The network keeps functioning, keeps reaching consensus.
Despite internal problems.
Right. So in theory, a well-designed swarm governance system could similarly absorb and isolate misbehaving elements without collapsing. It ensures continuous, robust oversight, which is paramount for critical AI systems. That's a stark contrast to centralized models, where taking out one key server or compromising one key authority could mean the whole thing down.
Okay, resilience is huge. What about speed? The regulatory lag we discussed is such a killer problem for traditional approaches.
Yeah.
How does swarm governance tackle that?
Yeah, agility is another massive potential advantage. With potentially millions of distributed agents constantly monitoring and interacting, responses can be virtually instantaneous.
Real-time governance.
Closer to it, certainly. Instead of waiting weeks, months, maybe even years for new legislation or for a bureaucracy to convene, debate, and issue new guidelines, the swarm reacts continuously.
Give us an example of how that might play out.
Okay, imagine a subtle but harmful bias accidentally slips into a newly deployed AI model on a major platform. Maybe a job application screening tool starts disadvantaging a certain demographic. In a traditional system, it might take ages for that to be noticed, reported, investigated, and maybe eventually corrected.
Lots of potential harm in the meantime.
Definitely. In a swarm governance model, however, the network of detectors within the swarm could potentially flag that bias almost immediately within seconds or minutes. They could then trigger an automated response,
Like what?
maybe automatically adjusting the model's parameters to counteract the bias, or quarantining the specific part of the model causing the issue, or just raising immediate urgent alarms to human supervisors. This fast feedback loop allows the system to adapt to novel AI risks, sometimes called zero-day model behaviors.
Like zero-day exploits in software. Unforeseen problems.
Exactly. Behaviors that weren't predicted or tested for. The swarm could potentially adapt to these in real time, preventing widespread harm before it even fully materializes. That speed is revolutionary compared to traditional regulation.
It certainly sounds it. Now, this is great for rapid response, but you also talked about pluralism, incorporating diverse values. How does the system actually handle conflicting ethical viewpoints or different legal frameworks across the globe? Won't different agents with opposing directives just cancel each other out, leading to paralysis?
That's a really important question. And the way the swarm potentially handles this is through pluralism via emergent consensus. It's not about enforcing one universal code, which is probably impossible anyway. Instead, a swarm can natively incorporate diverse values and contexts in a way a single authority struggles to.
How? by tuning the agents.
Yeah, exactly. Each agent, or maybe clusters of agents, could be specifically tuned to prioritize different ethical principles or enforce specific legal regimes. GDPR compliance agents, agents focused on fairness metrics for a specific region, agents upholding free speech principles within certain bounds, etc.
So you'd have this mix of perspectives embedded in the swarm itself.
Right. And the system wouldn't necessarily try to find one answer that satisfies everyone perfectly. Instead, it would vote or reach consensus on actions based on this distributed chorus of preferences and constraints. There would need to be predefined mechanisms for resolving lower-level conflicts, maybe weighting certain agent types higher in specific contexts, or applying a majority rule that emerges from all the local interactions.
So the outcome reflects a balance of the competing values present in the swarm.
That's the idea. It aligns strongly with democratic ideals, actually. As Bengio points out, true democratic decision-making involves decentralization of power and checks and balances to ensure that decisions reflect and balance the views of diverse citizens and communities.
So unlike a rigid one-size-fits-all law.
Right. The swarm's emergent policies could adapt to local norms and specific contexts while still coordinating effectively on a global scale. It's aiming for a dynamic, living form of global consensus, perhaps more like how complex societies navigate diverse views through ongoing negotiation and compromise, but operating at machine speed.
You keep mentioning blockchain, particularly around resilience and consensus. Can you elaborate on how that technology connects to the security and integrity of swarm governance? It feels like there's a really strong parallel there in establishing trust without a central middleman.
There absolutely is a strong parallel, and it's a key enabling concept. The success of blockchain tech, despite its volatility in other areas, vividly demonstrates that decentralized systems can manage security, trust, and value at immense scale without needing a central authority.
Through cryptographic consensus.
Exactly. In blockchains, participants follow strict consensus protocols like proof of work or proof of stake that keep the shared ledger of transactions tamper-proof and immutable, all without a central bank or government guaranteeing it.
So how does that apply to AI governance?
Well, by analogy, a sworn governance layer could utilize similar blockchain-style consensus mechanisms. These wouldn't be validating financial transactions, but rather agreeing on accepted AI behaviors, confirming adherence to ethical guidelines, or triggering specific pre-agreed sanctions against non-compliant AI systems.
Like an immutable log of AI actions and governance decisions.
Potentially, yes. If these protocols are coded correctly, cryptographically secured, and widely adopted, this could give us extremely high assurance that no single actor, whether it's a rogue AI, a malicious hacker, or even a powerful corporation trying to cover its tracks, could unilaterally alter the oversight rules, tamper with the audit trails, or bypass the collective governance decisions.
Making the oversight itself trustworthy and tamper-proof.
That's the goal. This principle of distributed, verifiable, tamper-proof agreement is a cornerstone of the kind of robust systems that initiatives like AI Coach by Anil Nathu are exploring for ensuring integrity in an AI-driven future.
Okay, this all sounds incredibly powerful, but still very futuristic, almost bordering on science fiction for some listeners, perhaps. Are there any concrete steps being taken today? Any early initiatives or practical examples that even hint at this vision of swarm governance starting to become a reality?
Yeah.
Where are the seeds being sown?
That's a fair question. While the full vision of a global AI governance swarm is definitely still on the horizon, there are early initiatives and research projects that offer promising glimpses into its feasibility and practical application.
Like what?
Well, in research, for example, swarm learning techniques are already being used. They've enabled distributed AI model training, particularly in sensitive areas like healthcare.
How does that work?
Individual hospitals or research labs can act as edge nodes. They collaboratively train a shared AI model by exchanging mathematical gradients information about how the model needs to learn without ever needing to pool or share the raw, sensitive patient data centrally.
So they learn together while preserving privacy.
Exactly. It's a distributed intelligence model already at work, solving real-world problems. That's a form of swarm intelligence in action.
Okay, interesting. What else?
On the policy and collective intelligence front, you have platforms like Unanimous AI's HiveMind. This system allows groups of humans to make joint forecasts or decisions through a digital swarm interface. And studies have shown it can actually enhance accuracy and lead to better collective decisions compared to traditional methods like polling or just averaging individual opinions.
So harnessing human swarm intelligence digitally.
Right. It demonstrates the power of aggregating intelligence in a swarm-like way. Looking ahead, pilot projects for AI governance could start small and focused, gradually building towards the bigger vision.
What might those pilots look like?
For instance, you could imagine a swarm of content moderation bots operating across different social media feeds. Instead of just one platform's AI or human team, maybe bots from various stakeholders use a voting or consensus mechanism to collectively flag harmful content like hate speech or deepfakes, distributing the load, potentially improving consistency.
Or maybe auditing algorithms for bias.
That's another great example. A network of bias detector agents, maybe developed by independent ethical AI labs or consortia. They could simultaneously audit machine learning models deployed by multiple companies, continuously monitoring for algorithmic bias. They could share findings, maybe anonymized across the network, to spot systemic issues and push for corrections before discriminatory outcomes affect millions.
These sound like practical first steps.
They are, and these kinds of prototypes would be invaluable, not just for testing the tech, but for figuring out the really tricky parts. How do you best encode ethical checks? How do you design the agent interactions? How do you effectively integrate human oversight? Maybe you have civil society groups acting as governor agents, auditing the swarm's decisions or having the power to intervene. This iterative, experimental approach is crucial.
This vision is incredibly compelling. It really offers a fresh perspective. But let's be realistic. Any paradigm shift this massive faces huge hurdles, right? What are the biggest technical challenges we need to overcome to make swarm governance work reliably? How can these emergent systems go wrong in unexpected ways?
You're absolutely right to press on the challenges. The path is definitely far from straightforward, and the engineering required is immense. One of the primary technical hurdles is preventing what researchers call pathologies from emergent interactions.
Pathologies, what does that mean?
It means unintended, harmful collective behaviors that can just emerge from the interactions of simple agents. Just like we saw natural ant colonies can sometimes get stuck in counterproductive loops, like endlessly circling a dead beetle.
Right, the antmill.
Exactly. An AI governance swarm could potentially converge on unintended behaviors too. Imagine agents becoming hyper-optimized for a minor metric, maybe engagement, while inadvertently amplifying subtle biases until they become systemic and damaging. Or perhaps they fall into a collective feedback loop that leads to overzealous censorship of legitimate discussion.
So the swarm could become robustly wrong.
That's the risk. It could be stable, but stabilize around a deeply flawed or harmful equilibrium. Preventing this requires extraordinarily rigorous design of the individual agent protocols, those simple rules each agent follows. We need to somehow guarantee that good or desirable norms consistently dominate the collective behavior.
How do we do that?
That's where cutting-edge research comes in. Fields like multi-agent reinforcement learning, studying how multiple agents learn to cooperate or compete effectively, and formal verification, using mathematical methods to actually prove that software meets certain safety or correctness properties, will be absolutely crucial.
So we need mathematical proof that the swarm won't go rogue.
Ideally, yes, or at least strong probabilistic guarantees. And beyond that, there's the challenge of fragmentation. We have to ensure the swarm doesn't just break apart into incompatible subswarms, where different clusters of agents operate under conflicting rules or just can't communicate effectively anymore. Achieving robust communication and shared protocols at a massive global scale across potentially millions of diverse agents. That is a non-trivial engineering challenge. It requires huge innovation in distributed systems design.
Okay, those technical hurdles sound immense. But what about the ethical and accountability issues? If a distributed system, a swarm, is making critical decisions about other AIs, and something goes wrong, who is ultimately responsible? This seems like a massive ethical and legal minefield.
It absolutely is, and it's arguably one of the biggest non-technical barriers. It's a critical point. In a highly distributed swarm, if that autonomous audit system fails, maybe it misses a critical flaw or makes a wrong judgment, and an AI system consequently causes real harm. Say a financial trading AI causes a market crash, or a medical diagnostic AI consistently misdiagnoses a certain group. Tracing blame becomes incredibly difficult.
The code made me do it problem.
Exactly. Who is liable? The designers of the individual agent protocols, the architects who designed the overall swarm interaction rules, the organization that deployed the AI system being governed, the entity that deployed the swarm itself. Our current legal frameworks just aren't built for this kind of distributed, emergent decision-making. We would need entirely new legal concepts and frameworks to assign liability effectively in a collective governance context.
And without clear accountability.
Trust evaporates, which leads to the next point, the fundamental question of public trust. Will people Citizens, consumers, even businesses actually accept critical decisions affecting their lives or livelihoods being made by what might seem like an inscrutable swarm of algorithms.
It sounds opaque.
It could easily feel that way. Overcoming the skepticism, building genuine trust will require radical transparency measures. Maybe an open, publicly auditable ledger of swarm decisions and their rationales. And definitely robust, human-in-the-loop guardrails, ensuring human oversight and intervention is always possible at critical points. These aren't just technical problems, they're deep societal challenges demanding careful thought and broad public discourse.
Building on that trust issue, a fully automated governance swarm, it might feel quite alien, even threatening to many people. It sounds like taking decisions completely out of human hands. How do we build public acceptance and social legitimacy for such a radical shift?
That's a profound social challenge, you're right. A fully automated system could easily feel like democratic control is being eroded, leading to widespread skepticism, resistance, maybe even outright rejection. Building that public trust and achieving social legitimacy won't happen automatically. It will require deep participatory design processes.
Involving the public in the design.
Yes, actively involving diverse communities, ethicists, civil society groups, legal experts in shaping the swarm's value setting, its operational parameters, its oversight mechanisms. It's about giving people a real voice in how these powerful systems are aligned with human values, rather than just having technology imposed upon them.
So co-creation, not just top-down deployment.
Absolutely. And hybrid models are probably key here. Models where humans and machines explicitly co-govern and collaborate might be the most pragmatic way to ease the transition, build confidence, and learn as we go. Plus, extensive public education and open dialogue will be absolutely essential. We need to frame swarm governance not as some scary AI takeover, but as a potentially powerful extension of human collective wisdom. Leveraging the speed and scale of AI to enhance our ability to manage AI itself, it's about empowering humanity with better tools, not disempowering us.
So given all these significant hurdles, the technical complexity, the ethical quandaries, the social acceptance challenge, is the most likely future actually a blend?
Yeah.
A mix of traditional governance structures augmented by swarm-inspired approaches rather than a complete replacement, a sort of hybrid governance model.
Realistically, yes. I think that's the most probable path forward, at least in the near to medium term. We probably won't see an overnight switch to a fully autonomous global swarm. It's more likely we'll see mixed architectures emerge.
Like how?
For example, traditional regulators might start by using swarm-inspired tools for real-time monitoring, anomaly detection, risk assessment, getting much better data faster while still retaining final human authority for making binding decisions or setting major policies. Companies could deploy internal swarms, maybe swarms of code review bots continuously flagging compliance issues or ethical red flags within their own AI development pipelines, integrating this into their existing corporate governance.
Using the tech internally first.
Makes sense, right? Even traditional AI oversight bodies could adopt distributed technologies incrementally. We might see things like secure, perhaps blockchain-based, registries for tracking the deployment and usage of high-risk AI systems, improving transparency and accountability, or federated monitoring systems for AI ethics, allowing multiple parties, regulators, auditors, companies to securely monitor models without necessarily revealing proprietary algorithms or sensitive training data.
Learning from other fields.
Definitely. We can draw valuable lessons from sectors that have already grappled with managing complex, distributed systems. Think about global financial networks. They rely on decentralized protocols to manage trillions of dollars in transactions across countless institutions without one single controller. Or look at internet governance bodies like ICANN or the IETF. They coordinate global standards through distributed, multi-stakeholder processes. These precedents offer valuable roadmaps for how we might incrementally roll out swarm-inspired AI governance.
So despite all the unknowns, all the significant challenges we've discussed, the potential payoffs for pushing forward with swarm governance seem incredibly high. By distributing oversight, we make AI systems inherently harder to corrupt, more resilient to failure or attack, and much quicker to correct when things go wrong.
That's the promise.
We also create a mechanism to actually give voice to multiple stakeholders, multiple perspectives, multiple values across the entire AI lifecycle. In effect, swarm governance could turn AI's own complexity, its own distributed nature, to our advantage. Harnessing those same forces of emergence and collective intelligence that make AI so powerful in the first place, to keep it aligned with what we as humans actually want. This really is the kind of forward-thinking strategy that AI coach by Anil Nathu is dedicated to exploring.
So, wrapping up this deep dive, it feels like exploring swarm intelligence has really opened up a compelling new perspective, hasn't it? It offers a powerful counter narrative to the limitations of traditional top down control for AI. We've laid bare how current centralized AI governance efforts are inherently challenged by AI's sheer speed, its escalating complexity, and that dangerous concentration of power. They're just not agile enough for this new era.
Definitely. And we've learned that nature itself, through phenomena like ant colonies and bird flocks, offers this incredible blueprint, a model for decentralized, highly resilient, and continuously adaptive systems, all based on simple local interactions leading to complex, emergent intelligence. It's a powerful testament to the wisdom of the collective and how we might harness it for our digital future.
And crucially, we've seen how these elegant biological principles can potentially be applied to one of the most pressing challenges of our time, governing advanced AI. We've envisioned this system, perhaps millions of micro AIs collaboratively auditing, monitoring, and correcting each other, like a living immune system for the AI ecosystem, importantly enhanced by human swarm synergy to maintain that crucial ethical oversight and control.
The potential benefits are really clear. Unmatched resilience against failure or attack, real-time agility to respond to new risks, an inherent pluralism that allows for diverse values to be incorporated, and the potential for high assurance through blockchain-style consensus mechanisms. But, as we've thoroughly explored, we absolutely must acknowledge and proactively navigate the significant technical, ethical, and social challenges that stand in the way. It's not a magic bullet.
Not at all. So for you, the listener, seeking to grasp this complex topic quickly and thoroughly, what are the practical takeaways? Here are some steps to consider, inspired directly by the adaptive nature of swarm intelligence we've discussed. These aren't just abstract ideas for policymakers. They can influence how you interact with and think about AI in your daily life and your work.
Adopt a decentralized mindset. Think Gardener, not just Guardian, personally. When you encounter a new AI tool, maybe a chatbot, a recommendation engine, whatever, start asking critical questions. How transparent is its decision-making? Can you get any sense of its underlying logic, its local rules? Don't just blindly trust centralized claims of safety or ethical design. Seek out distributed reviews, look for community feedback, maybe explore open-source alternatives that allow for more scrutiny. Cultivate a diverse understanding. Don't rely on one source. Professionally, within your organization, try to advocate for modular, more transparent AI systems. Could you encourage internal audit bots or simple peer review mechanisms for AI models? Maybe different teams or even different automated agents could act as checks on each other's work? This distributes the oversight burden beyond just a single, potentially overloaded compliance department. It fosters that Gardener mentality.
Okay, decentralize your thinking and your approach. Makes sense. What's next?
Second, foster local interaction in AI development. Connect the nodes. Personally, get involved. Engage actively with AI communities that emphasize interaction and collaboration. This could mean contributing to open-source projects, participating in forums discussing AI ethics and best practices, or just sharing your experiences. Your individual input, even if it seems small, like that single ant's pheromone trail, contributes to the collective intelligence and refinement of these systems. Every voice can matter in a swarm. Professionally, implement more regular local peer review loops during AI development. Don't just wait for one big final audit at the very end. Encourage smaller, cross-functional teams to continually test, validate, and provide feedback on different components of an AI system as it's being built. This distributed, continuous feedback helps catch anomalies, biases, or unexpected behaviors much earlier in the cycle, making correction far more efficient and less costly.
So more interaction, more feedback, earlier, and more often.
Got it. Third, prioritize adaptive learning and feedback. Cultivate an evolving immune system. Personally, stay curious and stay informed. The landscape of AI risks and governance solutions is changing constantly. Cultivate a learning mindset that embraces continuous adaptation, just like a swarm adjusts to new food sources or threats. This ability to learn and evolve your own understanding is absolutely essential for navigating the AI future, and it's a core principle here at AI Coach by Anil Nasu. Professionally, design your AI deployments with rapid feedback loops built right in. For example, if an AI system makes a decision that gets flagged as potentially biased or harmful, ensure the system can immediately signal this, alert human supervisors, and has mechanisms for rapid, perhaps localized, adjustments or corrections. Don't wait for a 6-month review cycle or a major regulatory overhaul. Build in the capacity for immediate course correction, creating a more robust, self-healing system.
Building in adaptability from the start.
Crucial.
And the last one.
Fourth, explore hybrid models bridge the old and the new. Personally, When using personal AI tools, think about how you can maintain oversight. Can you use governor settings or human-in-the-loop features? Ensure you retain ultimate control and can inject your own values or override automated decisions when needed. It's about creating a partnership with AI, using it to augment your judgment, not replace it entirely, professionally. Don't wait for the perfect, fully autonomous swarm governance system to magically appear. Start today by integrating swarm-inspired tools and principles within your existing frameworks. Use distributed monitoring systems. Employ collaborative decision-making platforms. Maybe deploy internal AI agents just to flag potential compliance issues or monitor ethical guidelines, with human teams still providing the final review and making the critical judgments. This eases the transition, builds familiarity, and delivers value now.
So, putting this all together, what does it mean for you navigating this incredibly complex and fast-moving landscape? Maybe instead of focusing solely on crafting rigid, backward-looking rule books for AI rules that are almost guaranteed to be outdated before the ink is dry, maybe we need to shift our focus. What if we started thinking about building living governance systems? Systems that can grow, adapt, and evolve right alongside intelligence itself.
Exactly. Picture governance not just as a static set of laws etched in stone, but as a dynamic immune system for our increasingly digital world, constantly sensing threats, identifying anomalies, mobilizing coordinated responses before misuse or catastrophe can spread widely. In a future like that, maybe each of us does have a personal AI delegate, a digital avatar that represents our specific values, our ethical preferences, our legal boundaries within the broader governance swarm.
Our voice in the swarm?
Precisely. These delegates could form dynamic communities of interest, ensuring that even niche viewpoints or minority concerns get checked, weighed, and incorporated into the collective decision-making process. Ultimately, the swarm wouldn't just regulate AI from the outside, it would be an evolving form of collective intelligence itself, mirroring humanity's own incredible diversity and learning capacity, but operating in real time at machine speed.
As Yoshua Bengio cautions, maybe the only truly safe way to govern intelligence that could potentially surpass our own is to build governance that itself grows, adapts, and evolves. Embracing a swarm paradigm might feel counterintuitive now, a real departure from our deeply ingrained centralized thinking, but it could very well be the key to unlocking a resilient, democratic, and genuinely robust AI future. This kind of innovative, boundary-pushing thinking is exactly what defines AI Coach by Anil Nathu, and that wraps up our deep dive into the fascinating world of swarm intelligence in AI governance. We really hope you found this exploration as thought-provoking and maybe even as mind-bending as we have. It certainly challenges our preconceptions about how we build a safe and ethical future with AI.
The ideas we've discussed today, drawing inspiration from nature and early tech, offer a powerful new lens for thinking about AI oversight, one that moves beyond the clear limitations of traditional models. We strongly encourage you to continue exploring these concepts, maybe look into some of the research or pilot projects, and definitely consider how these decentralized adaptive principles could apply to your own understanding and interaction with AI, both in your personal life and your professional world.
Thank you so much for joining us today. Visit the AI Coach website for more AI insights.